Hi guys, my name is Mikhail Davidov, and today's lightning talk will be about testing tools that you use to test your JavaScript applications. Here are the topics that we will cover today. We will start from classifying tests and testing tools. As you see, there is a lot of ways that you can classify your tests and your testing tools. And we will use most of those in this presentation. Your tests may be of a different level, like unit tests, integration tests, or component tests, and finally end-to-end tests. In this presentation, we will cover unit tests, a little bit of component testing, and functional testing for web. We will not cover non-functional or API testing or mobile. And we will start from unit testing. So which tools you will need to write your unit tests in JavaScript? First of all, you will need a runner. In Java world, you have JUnit. In JavaScript world, you have Mocha, Jasmine, Jest, Eve, or Ava, Cucumber, Top, Tape, and many others. Second thing you will need is assertion library. All your tests need to verify the output from your functions. It will need to verify behavior of your application, and this is where assertion libraries comes into picture. Many runners have integrated assertions libraries. Some, like Mocha, doesn't. Some tools like Jest and Ava provides pretty interesting kind of assertions called snapshots, when you have some kind of a baseline, and when you're running tests, you are comparing the actual output to the recorded snapshot, which is a baseline. It's pretty handy for testing rendering, and this is what most of your front-end code is about, right? Spice and mocks are very important in the unit testing, because you want to test your modules in your components in isolation. And tools like Sign-On or Test Double actually come to help you there. Important thing is part of unit testing for front-end is mocking HTTP requests to your API services. It is what most of the pages actually do, and you don't want to hit the real backends. Again, because we're talking about a front end, you will need to somehow run your components either in a browser or in an environment similar to browser. So some tools, some runners such as Karma, allows you to run tests in the browser itself. And if you're running tests in Node, you can also emulate your browser using libraries such as GSDOM. And GSDOM is integrated in many runners, including Jest. And finally, we will need support for our front-end frameworks such as React, Angular, or Vue or the other framework that you are using. Yeah, there are different approaches for that. Here, let's talk about them. One example of React. For React, the most popular libraries representing each of those approaches are React Testing Library, which is about black box testing. So they are trying to emulate the behavior of your application and user actions, and Enzyme, which is very tightly integrated with React and allows you to go deep into the internals of your React application. And the difference of approaches is that if you are writing tests using Enzyme, you don't have to modify your application. Usually you can test anything that you've written in using React. And if we're talking about React Testing Library, it promotes and requires some testability from your application, which actually usually promote better design. And also it allows you to find the bugs that user will find because they are not testing the implementation. They are trying to test the behaviors. This is the main difference. And also, testing library have a really nice example where we can see all the tool types that we discussed playing nicely together. So we are importing stuff from the testing library itself, which is providing some support for testing React. As we see, we're also importing some expectations or assertions from testing libraries. This test is using Jest Runner, which is, well, pretty something you can expect because we're testing React application. And the first statement is we are mocking the Axios, which is the library that is doing HTTP requests. So the structure of your test is pretty typical. So first of all, you are doing some mocking. Then you are actually executing some actions against your application. In this case, we are rendering a component. Then we are emulating the click. And finally, we are doing quite a lot of assertions. So we are, first of all, checking our mocks. We're checking that particular function of Axios mock has been called in this get action. We're checking which parameters were passed to this function. And finally, we are verifying what the user would see on the screen. And this screen object is provided by the testing library. You see we're using it here to get some elements as well. Okay. If we go to Enzyme, in the example, it has pretty similar structure. But again, the internals are pretty different because here they use a lot access to internals of the React. And for instance, shallow rendering is not available in React Testing Library because it's very React thing. Also, you can see that here they use a Chai assertion library. They are using sign-on, spies, and mocks, and which tells us that probably this is Mocha. It's not Jest. Okay, so Let's move further. The next thing we will discuss are runners. Here I have the most popular runners for JavaScript. Mocha, which is the most popular standalone runner. It doesn't have assertion library. It doesn't have spies or mocks, but it's simply the most popular runners out there because it has a tons of extensions of third-party plugins, and also it's very configurable. Unfortunately, it doesn't support parallel runs, unlike some other tools. Jasmine is a tool written by Google, mostly for testing Angular applications, but you can use it with any framework you want. It's all-in-one tool. It has mocks, spies, it has assertions. It has a smaller footprint than Jest. It's a little bit less feature-rich, but it still will provide you everything you need to write your tests. Both Mocha and Jasmine allows you to run tests in different browsers. Jest is simply the most feature-rich runner out there. It's written by Facebook. It's intended for using for testing React, but you can use it for testing any other Node.js code you want. It runs tests in Node.js, not in your browser, but it integrates tightly with JS DOM to emulate your browser environment. And it has a really nice feature such as snapshot assertions that we talked a little bit about, and parallel runs. AVAR is pretty new and pretty different. It is an opinionated runner. It doesn't have globals, for instance. You have to import everything from AVA directly. It doesn't have hooks before or after. It do have a parallel runs, and it do have a snapshot support, which is pretty nice. And also it only works in Node.js, not in your browsers. And finally, we can discuss the functional testing, most interesting part. By functional testing, I mean component and end-to-end testing of your front end. You will need a runner. You can use the same ones that we discussed for unit testing. You will need assertions, but there are some other different kinds of assertions called visual regressions. And it is provided by vendors such as Applitools or Percy. It costs quite a lot of money. And it is actually cloud services, because what you use visual regression for, you're using it to compare screenshots or videos of your application to some recorded screenshots. So you need a lot of storage, and you also need some tools to AI-assisted tools to compare your screenshots, and you need a nice UI that will show you the difference and store all the test runs. And this is what Percy and Applitools are providing. Mocking is almost non-existent for end-to-end tests, because you want to test the system as a whole. So you don't want usually to mock component. But if we're talking about component testing, you might need to mock your HTTP requests, and tools like WireMock, which is not exactly the JavaScript, it's more the Java application, but it has nice JavaScript bindings. So this is where they come into picture. And finally, we have a driver, which allows you to run tests in a browser to emulate the user actions such as clicks, navigations, to have access to your HTML elements, etc. So most well-known family of tools are based on the W3C WebDriver or a JSON-wire, a Selenium JSON-wire protocol. The most well-known probably is Selenium, but it is also the one that used the least in the JavaScript world, but used quite a lot in Java. There is Protractor, which is mostly used for Angular applications. Here is Nightwatch, which was a pretty nice tool, but it is a little bit outdated. And the most robust and modern tool for functional testing using WebDriver protocol, which is WebDriver.io. And there is another set of tools that does not support the W3C protocol and have a little bit more limited compatibility with browsers, which are Cypress, Puppeteer, and TestCafe. So we will talk about them a little bit further. So WebDriver-based tools, how they work. You have a library, which is kind of a client library client of your WebDriver. It communicates with its server using W3C WebDriver or JSON-wire protocols. It can directly work with drivers such as Chrome driver or Firefox driver or a driver for any other browser, or there can be an intermediary or proxy in between your client and Chrome driver. What I mean by intermediary. So it can be one of the cloud service providers we talked about a little, which are Sauce Labs and Browser Stack. It can be a Selenium grid, which allows you to have Selenium installed on different nodes in the different virtual machines and spawn different browsers on each of those nodes, or Selenium standalone, which will allow you to run multiple browsers on your own machine. Well, what's good about it? It's very stable. It is a W3C standard. It is supported by each and every browser. It has a lot of client libraries, a lot of frameworks based on the WebDriver protocols. There are providers such as Sauce Labs and Browser Stack, but actually there are more that will allow you to test your how your application work on different devices, on the very different versions of browsers, on the different operating systems. What's not that fun about it is it's much slower than other tools because it involves a lot of actually communication over HTTP. And if we're talking about like Selenium Grid or browser stack, it will go all the way across the globe, here, there, and back. The latency may be like hundreds of milliseconds for each request. And believe me, there is quite a lot of requests that your client is doing. And the other thing which make it a little bit hard to write your tests is that you need to write synchronization statements yourself. So you need to wait for your component to transfer to expect some state, some particular state, and Selenium itself, driver itself, doesn't know anything about what this state is. So you will have to implement it yourself. Cypress is pretty new and extremely popular, especially amongst developers. It's an all-in-one tool that provides a really seamless experience, because which includes its own IDE, debugging, reporting, screenshots. It doesn't have issues with synchronizations, because it tries to do most of the synchronization automatically, and it is very much faster than WebDriver. But also the architecture is pretty different. So here you will basically have Cypress code executing in one of the iframes, and your application executing in the other. And your test will be executed in the browser and not in the Node.js, and it will make it much faster. Puppeteer is one other tool that is used a lot for functional testing. It is actually implementation of Chromium DevTools protocol. Puppeteer is written by and supported by Google. It's very fast. It can do anything you may think of with your Chrome, and also it has a really complex API. And I wouldn't say that it's very stable. And finally, WebDriverIO. In my personal opinion, it's one of the best tools out there for functional testing. First thing, it integrates with a lot of other tools, and it have a integration with Puppeteer. So you can combine your end-to-end testing with component testing. It has full support for W3C WebDriver protocol. It also integrates with Selenium. It can work with any of the providers we discussed, like Sauce Labs and Browser Stack. It can, instead of writing web tests, you can write tests for your mobile application using Appium. It integrates with two runners, Mocha or Jasmine, but it is built on top of them and have some other features such as retries, support for parallel runs, etc. Interesting thing is that it allows you to write your tests asynchronously. You don't need promises, async awaits, etc. if you use the WDIO sync module. But you can write your code, your tests asynchronously if you want to. And it has pretty nice and simple API. It has a free global object like browser, which allows you to do navigations and switching between windows. It have a dollar, which is pretty similar to what you have in like jQuery. It allows you to get an element and control it, and $, which allows you to get several elements and do something with them. And finally, let's see how all the tools work together to allow you to write all the required testing types, right? So for unit tests, you can use Enzyme or a testing library for your functional tests. All the runners that we discussed can be used for any of those testing types, like Jasmine, Jest, Cucumber, Tap, Tape. They can be used for all of the above. Karma is mostly for unit testing, but because it allows you to run anything in your browser, it's also pretty good for component testing. But Karma is a little bit outdated. Not many people are using Karma nowadays. WebDriver has, as mentioned, nice integration with Puppeteer in other tools, and thus it can be used for both end-to-end and to some extent for component testing. Cypress, I would say, is mostly meant for component testing, especially the features for mocking your HTTP requests. And Test Cafe is pretty similar to Cypress in architecture, but it doesn't allow you to mock requests, thus it is mostly for end-to-end testing. And here are the resources that I used to prepare this presentation. Guys, thank you very much.